We're going to look at how to evaluate and graph piecewise functions in this video. A piecewise function is one that has more than one part or piece. So here's an example. Suppose we have a function f of x equals x minus 2, 2x, and x plus 3. Now after each one of these pieces we have the particular boundaries that they're valid for. So we would use a piece x minus 2 when x is greater than or equal to 1. We would use a piece 2x when x is between -1 and +1. And we'll use x plus 3 when x is less than -1. So suppose we want to evaluate the following. We need to find f of 5. Okay, so this means that the x value equals 5. And we've got to decide which piece we have to use. So we go up here and take a look at each one. Alright, if x is 5, then is 5 greater than or equal to 1? Well, yes it is. 5 is greater than or equal to 1. So we're going to use piece number 1 for the number 5. So we need to plug in 5 for x in piece number 1. So putting the 5 in up here, it'll be 5 minus 2. When we do this calculation, we know that the output would be 3. So that's kind of the approach. Let's do the next one. F of 0. This means that x equals 0. So we have to decide which piece we're going to use. So let's go up here and look at the top one. Is 0 greater than or equal to 1? No, not really. What about the middle piece? Is 0 between -1 and +1? And it is. So we'll use piece number 2. So we're going to use piece number 2, which is 2x. And I need to plug in our number 0. So this would equal 2 times 0, which equals 0. And now let's look at the last, f of -2. So looking through these pieces, I know that -2 is less than or equal to -1. Since -2 is smaller than -1, it was less. So we'll use piece number 3. And I'm plugging in -2 in this piece, so it'll be -2 plus 3, which is +1. And those are the outputs or the y values. So we could think of these as y values. So each one of these would be a point. This would be 5, 3. The next one would be 0, 0, and -2, 1. Now let's take this function and see how to graph it. So this is our function again, and I'm going to show you how to look at each piece and graph each individual part. So right now I have it set up as individual pieces and the requirements for each piece. So piece number 1 is x minus 2, and x has to be greater than 1 with that piece. So in order to graph this by hand, what we'll do is set up a table, XY table, and choose values of x that are greater than 1. Okay, x has to be greater than 1. So or equal to 1 actually. So let's start at 1, since x could equal 1, and then maybe 2 and 3. So I take those numbers, 1, 2, and 3, and I plug them into the piece right here. So y would be 1 minus 2, which is -1. Next, if I plug 2 in up there, that'd be 2 minus 2, which is 0. And then plug in 3 up there. 3 minus 2 is 1. Alright, so we've got points. Our first point is 1, -1. Our next point is 2, 0, 3, and 1. So I go over to the graph and let's plot these points. Okay, so over 1 and down 1. Okay, this is a point 1, negative 1, over 2, down 0, so right there at 2 we have the next point, and the last point is 3, 1, so over 3 and up 1 will be right about there. Okay, so then what I'll do is connect these dots, these points, and that'll give me the first piece. Alright, now notice one thing though, x is greater than 1, greater than or equal to 1. That means that this will keep on going forever. Okay, so that's what that piece looks like. Now let's move on to piece number 2. This is y equals 2x, and the boundaries are between negative 1 and positive 1. So when we set up our table, let's choose the endpoints. Let's choose negative 1 and then zeros between negative 1 and 1. And let's choose the other endpoint of positive 1. Now, since there's no equal sign right here, no equal sign, and also over here there's no equal sign, that means that this point will be an open point. And this one down here will also be an open point. So these are not regular points that we think of when we graph a function. They're going to be open points because there's not an equal sign at negative 1 and positive 1. Alright, so we'll keep that in mind when we graph these. So now we need to figure out these y values. So we'll take negative 1 and plug it in. So 2 times negative 1 is negative 2. Then we'll plug in 0. 2 times 0 equals 0. And then plug in 1. 2 times 1 equals 2. So now we have the particular points. We've got negative 1 to negative 2. So let's graph that one. Okay, over negative 1, down negative 2, so right here. And remember, this has to be an open dot. So let's include that. There's an open dot right there. Next point is 0, 0. That's a regular dot, a regular point, a closed dot. So 0, 0 is right here. And the last point is 1, 2, and that has to be open as well. Over 1, up 2, right up here. So now I'm going to connect these points, and we have our middle piece, piece number 2. And the last piece, let's deal with that. This is valid for x less than or equal to negative 1. So let's set up our table again. Let's start at negative 1. And numbers that are less than negative 1 are negative 2 and negative 3. So we'll plug in negative 1. That's negative 1 plus 3, or 2. We'll plug in negative 2. Negative 2 plus 3 is 1. And then plug in negative 3 plus 3 is 0. Alright, so these are our points, starting off with negative 1, 2. Now notice there's an equal sign up here with this symbol, so that means we'll have a closed dot. We don't have to worry anymore about the open dots. So over here, negative 1, 2. Right up here. Okay, the next one, negative 2, 1. Over negative 2, up 1, right here. And the last point is negative 3, 0. So right about here. So we'll connect these dots and keep the function going over to the left. Since x is less than negative 1, it keeps on going. Alright, so we just graphed this piecewise function with 3 different pieces. Now let's look at one more. The function is g of x equals 4 for x greater than 0, and negative x plus 1 for x less than or equal to 0. So again, let's start by finding these values. G of 2. So we need to decide which piece we're going to use with the value 2. Again, this means x equals 2. So is 2 greater than 0? Yes. So we would use this first piece, and the first piece is just the number 4. So we can't plug in our value of 2 for x because there's no x in that piece. So we just get 4. Alright, now look at the next one. 0. We would use the second piece because 0 equals 0. So we'll plug in 0 here. So this will be negative 0 plus 1, or just 1. And this is the answer for that. Our next number is negative 3. And negative 3 is less than or equal to 0. So we would use piece number 2. And plug in negative 3. Now notice we already have a negative in the piece, so it's right there, and then I'm plugging in my negative 3 value. So minus a negative is really a plus, so this is really 3 plus 1, or 4. And then look at 6 and deal with that. 6 is greater than 0, so that would be the first piece. And we would have the constant of 4. Okay, so the points would be 2, 4, 0, 1, negative 3, 4, and 6, 4. Alright, and last we'll graph this function. So I already wrote down my pieces and the values that they're valid for. So piece number 1, we could always get the value 4 for that, regardless of the x value. So we're looking at x is greater than 0. Okay, so let's have our chart here. Let's start at 0, and the y value would be 4. Okay, numbers that are greater than 0, maybe 1 and 2. And we're always going to get 4 for y. Okay, so I'll just write that down. Now at 0, notice there's no equals. So we're going to have an open point right here with 0, 4. So going over to the graph, the open point is 0, 4. Over 0, up 4 would be right about there. And then 1, 4, over 1, up 4, and then 2, 4, over 2, and up 4 right here. Alright, so connecting these dots, we'll have a function going off to the right. Now for piece number 2, we'll set up a table again. And now we're looking at values where x is less than or equal to 0. So let's start at 0 and go less. So negative 1, negative 2. So we're going to take these numbers and plug them in to the function. So negative 0 plus 1 is 1. Negative 1 plus 1. Okay, got to be careful here. Again, we've got the negative right there, and then plugging in the negative 1, okay, that will give us a positive 1 plus 1, or 2. And then plugging in the negative 2, again, we have the negative with the function, plug in the negative 2 plus 1, so that would be just 2 plus 1, or 3. So now we have our points. Our first point is 0, 1. So we'll go over 0, up 1. Our next point is negative 1 here, and then 2. Go over negative 1 and up 2, so right about here. And our last point is negative 2, 3. Go over negative 2 and up 3 right here. So we'll connect these points and get the other piece going over to the left. So that is the answer for the graph of this piecewise function. Be careful when you have open points. Make sure you know where they are. And they occur when you do not have an equal sign. And then just connect the dots and you'll get your graph.